everyone, and welcome to yet another one of xgeeks live streams. We are super happy to be here with you once again. For those of you who are new to our live streams, welcome. And for those of you who have joined us in previous sessions, I am super happy that you're back here with us. I'm Beatriz, I'm part of the xgeeks team. And for those of you who have not heard about us before, allow me to quickly present our company. So we have two main verticals of focus here at xgeeks, e-commerce and cloud native. And we consider ourselves experts in e-commerce by implementing from software as a service and license to tailored engineering, and in cloud native by unblocking agility and innovation in hybrid and multi-cloud projects. We represent what we believe to be the perfect balance between product and project. If you are curious about us, you should definitely check out our social media and our website. And if you're interested in more content, don't forget to follow us on LinkedIn and YouTube as well to keep up to date. And I know you guys are not here to listen to me, so without any further ado, allow me to call Kevin to stage here. Thank you, Kevin, for being here with us today. How are you doing?
Glad to be here. I'm great. How are you?
I'm good as well. Thank you. So, Kevin, before I leave you to do your awesome presentation, allow me to just do a quick reminder to everyone at home watching us that you can leave your questions in the comments and we will get back to them at the end of the session so you can ask everything you need from Kevin. And Kevin, the stage is all yours, and have fun, everyone.
All right. Thank you. All right, so I hope you're excited about this session. I'm going to be talking about cloud native CI/CD with Tekton and ArgoCD. So those are two projects that I'm going to be talking about today. Quick introduction about myself. So I'm Kevin Dubois. I'm based in Belgium. I'm a developer advocate at Red Hat with about 18 years of experience building and delivering software applications. So I'm kind of my background is software development, but I was always kind of the one that also did, a lot of the delivering part because nobody else wanted to do it. So anyway, so my passion is really about, software development, developer experience with open source, and open source is really close to my heart. And it is also something that, Red Hat does really well. It's all that Red Hat does. And so I'm, happy to be working for such a cool company. Anyway, you can find me on LinkedIn, Twitter, Mastodon, Blue Sky. I have a YouTube channel and so on and so forth. So feel free to follow me. I'm probably the most active on Twitter, but any of those channels, I'd be happy to see you there. I try to post, kind of stuff around that cloud native development world, the Java world as well. Speaking of Java, next week I'll be in Coimbra, and I hope I pronounced that well, in Portugal for JNation. So if you're going to JNation, please come see me there and come say hi and maybe mention this show. That would be even cooler. Anyway, let's jump right in. So maybe you've seen this, maybe you haven't. I like this representation of kind of the development cycle. So you have kind of the inner loop of your development where you're doing local development. You're writing your code and you're doing your Maven builds or whatever builds. I guess it's not just Java. You're doing testing, debugging, and all that stuff. And at some point, you'll have an application or something that you're happy with, and you'll create maybe a pull request or a merge request, or maybe you'll push it directly to to a main branch. But you'll end up kind of in another cycle, which is the outer loop, where somebody might do a code review and there'll be some CI/CD process. You'll do maybe some security checks, compliance checks, and some more integration tests, and so on and so forth. And then from that outer loop, eventually, ideally at least, you'll go to production. So that's kind of the difference between those two. So the inner loop is really the local development, or in a cloud IDE or whatever, and then the outer loop development where more people, I guess, get involved in the process. So today we're going to focus mostly on the outer loop. of course, right? Because the session said a cloud native CI/CD, which is definitely in that outer loop of the cycle. And so I'm sure you've seen similar things where, like traditionally we'd have kind of bigger applications, monolithic applications, and we would deploy them typically not every minute, right? It would take a while because you have a lot of different people working on the same code base. You have to orchestrate everything, and it's usually kind of a big bang release that you would need to, make sure everything goes well. And so typically, might be every month or every X amount of months, or if you're really good, a few weeks. But but newer deployments, newer applications are typically more distributed, where you have more control over which components you're going to release. You can go faster to market. You can have distributed teams and applications. But in terms of delivering the applications, there's a different kind of complexity, right? So you have a lot more different applications and components that you need to deploy. And so here in this representation, you see those little tubes that represent basically CI/CD pipelines, if you will, to represent that, instead of having one release, now you have to manage, so many different releases. And so you have to kind of rethink how you're doing your, continuous integration and deployment. So when we're talking about continuous integration, you have kind of CI, CD, and CD. So CI, continuous integration, you have your build, your test, your security checks, ideally, maybe some more steps, and then you'll do some sort of a release or have some sort of release. And then, that basically is the continuous integration cycle. And then you'll deploy to staging and production, and you'll have, automated ways to do that with continuous delivery and continuous deployment. The main difference kind of being that, continuous delivery typically is where you have a deployable state, but you're not actually going to production in an automated way. So not after you commit or your merge requests and everything are approved, it won't go automatically into your production. You'll have some sort of manual step, where somebody says, yes, this is good, we're going to deploy it. And continuous deployment really being, we're going to, as soon as the code is merged into a certain branch, the main branch, for example, we're going to automatically deploy it to production. So that's kind of the difference between those two. So before we go on further, let's look at how we can do continuous delivery of a racing game. So that's going to be kind of the theme of this session. So we have a game, we have a certain feature, and then we're going to deploy a new feature. So I am counting on you to participate. So I hope there's a few people that are following live. And so basically, we're going to have this game, and you're going to participate in it. So get your phone ready, because you're going to scan a QR code to play along. Okay. So on the left side here of the screen, and I'll share the QR code in just a minute. But so on the left side of the screen, you see kind of what you'll see once you get access to the game. You'll see this little windmill, and you'll see kind of a randomly generated nickname and a team that you're in. And then basically what you're going to need to do is you're going to tap your screen to create wind energy to power these little cars. So you see here on the right side, you have a racetrack, and you have two little cars, and basically you're going to be powering those cars. So the participants are going to be separated into two teams that are going to play against each other, just randomly divided. Okay, so what is the architecture of the game? So basically, when you access it on your phone, we'll make a REST call from the game to my server here to assign a player name that's going to be random, and it's going to be stored in an InfiniSpan caching database, basically. And then once you start tapping, you'll generate REST requests for every time you tap. It'll go to our little game, to our server. That's gonna read the request. That'll accept the REST request, and it'll insert into a Kafka cluster. And then my dashboard will read those events, and that's gonna basically power the car. So that's kind of the architecture of the game. And the game itself is written with Quarkus, which is a Java runtime. If you're not familiar with Quarkus, it's a really cool way of writing Java because you have live reload, so you don't have to recompile every time manually to see your changes, so it happens automatically. And Quarkus is super fast too, so it does a lot of build time optimization so that you can use it kind of in serverless and cloud native deployments where traditional Java might be a little slower. So if you haven't checked out Quarkus, definitely do. Anyway, are you ready to play the game? We'll see if anybody's willing to play, and I hope you all do. So please scan the QR code, and then I'm gonna pull up my dashboard here. And I'm gonna move it to the side real quick, and then hopefully we'll see some players arriving in the game. So make sure to scan the QR code, and I'll do the same thing. I'm gonna scan it too, and I'm hoping Beatriz is around too. And so if you scan it, you'll see, like waiting for game. And so I'll give you another minute to scan the QR code. And I see that randomly assigned users are both, there's only 2 users. So I need, if anybody is around, please scan it, because right now our 2 players are assigned to the same team. And we have another player joining, and somehow randomly it's also assigned to team 1. So that's going to be, now we have some more players on team 2. And so if everybody's ready, I'm going to show you the dashboard. So if you're around, definitely scan the QR code real quick. And if not, I'm going to deploy our game here. Okay. And so let's do it. Let's start the game. So if everybody's ready, okay, so it says waiting for game, but now I'm going to hit start, and you're going to tap on your screen to make the cars go. Okay, so 3, 2, 1, go. All right. I'm tapping. Ooh, team 1 is the fastest right now, but team 2 is catching up. Tap more, tap more. Team 1 is definitely in the lead. It doesn't matter how many people are in each team because it's the average. So if I tap slower, I'll see that team 1 is slowing down. Oh, and now we're catching. Oh no, team 2 is the winner. So good job, team 2. And so this is kind of a funny way to play around with Quarkus. But so what we did here is we had this Quarkus game that we created Kafka events for, and so that was kind of funny. But now let's go back to the slides, and we'll continue with the presentation. But we're going to be deploying a new version of the game towards the end of this session. So please stick around and make sure that that you have your phone around, because what if we added a new feature to our game? So this time we tapped on our phone, but what if we, instead of tapping on our phone to create wind energy, supposedly, right? What if we shake our phone? It's a little more realistic, right? So we're creating wind energy by using the accelerometer of our phone. So, I'm going to be developing this new feature and then deploying it, with cloud native CI/CD. So, and as a proper developer, what we like to do is we like to be developing during the week, and then gets to where it's Friday afternoon, and then I'm just finished with my feature before the weekend, so I'm like, yeah, cool, here, ops, deploy my game, and that's it, right? And ops is like, seriously, Friday 5 p.m. And what happens, of course, is that the game gets deployed, and Friday night we get called in the middle of the night because there's something didn't go right. So ideally, that's not the way to go. So if we go back to our inner loop, outer loop. So let's say that I'm developing my code in my inner loop, and then I made a pull request, and the code got merged. So ideally, what we want is in that outer loop to have processes to simplify the way that our deployments work, so that our ops person isn't like, man, now I have to do a release on Friday at 5 p.m. and get everything configured and blah, blah, blah. So, ideally we can automate a lot of that. So that's what we're going to do in this session, is look at how we can do that. And so, the first part is the CI part of the CI/CD. So cloud native CI/CD typically is using containers, right? Cloud native is using containers, and potentially also serverless. So, with cloud native CI/CD, the idea is that we create declarative pipelines where we only run the tasks that we need to at the moment that we need to. We create a container and then we scale it back down. So really kind of serverless CI/CD, and that's going to help us a lot consume, reduce the resources and have a declarative way to do CI/CD. So why would we want to do cloud native CI/CD versus kind of more traditional CI/CD? Think of maybe a Jenkins, for example, right? So the traditional CI/CDs, they were more designed for virtual machines, kind of the same as the monolithic applications, long running on big servers and virtual machines. And you would typically require, IT operations for the maintenance of those servers, right? Keeping those Jenkins or whatever servers running and configured and everything. And then you probably have plugins, and they're shared across the entire kind of system. So those CI/CD engines are quite big, and there's not necessarily interoperability with Kubernetes resources. Maybe you can also spin up containers with Jenkins, but it's a little less native, right? So cloud native CI/CD, the idea is that it's really designed for containers, for Kubernetes, with pipelines as a service, with no operational overhead. So you just declare your pipelines and there's no kind of maintenance of any server that you need to do. And then the pipelines can be completely isolated from each other because they just run kind of in isolated containerized processes. And so everything can be lifecycled as container images, gives you a lot more flexibility and, and a lot more creativity to create pipelines. So one way to do cloud native CI/CD is with Tekton. And so Tekton is an open source project. It's part of the CNCF, so the Cloud Native Computing Foundation, which has, for example, Kubernetes is one of their projects too. And so the CD Foundation, which is part of the CNCF, is basically the steward of the Tekton project. Tekton being a project that's being worked on by Google, Red Hat, CloudBees, which is actually the people behind Jenkins, IBM, Elastic Puppet, and a lot more. So it's a project that's that's used by several of the major open source contributors. And so some concepts in that Tekton world are the following. So Tekton basically is a typed way to do pipelines. So you have certain types, which I'll show in just a second. It's decoupled, it's cloud native, and it's declarative. So we can just declare our pipeline, how it's supposed to be. Everybody can see it, can read it. It is YAML, of course, because it's kind of the Kubernetes world, but everybody can declare it and see it. So some of the concepts, some of the pieces of Tekton. So you basically, at the core, you have steps and tasks. So you have a task, which is basically a list of steps, and the steps can be, Maven install, or Maven test, or Git clone, or Docker build, or something. So those are steps, and you can have multiple steps in a task. And a task is basically a deployable unit. So that's what you would run, as a container. So it can have one step, or it can have multiple steps. So then tasks are grouped in pipelines. So on the right side, you see a pipeline is basically a grouping of tasks together with pipeline resources. And so those resources can be something like the source code repository link, or container images, or those kinds of definitions that you would need in addition to running your tasks, right? Because you need some sort of state. And then you have the implementation of a pipeline, which is a pipeline run. and that's a Kubernetes custom resource, just like all the other components, and a task run, which is, of course, the implementation of a task. So those are the main concepts in Tekton that you would need to create a pipeline with Tekton. So yes, a little bit of YAML once in a while. So this is a very simple representation of a pipeline. So you can see if you're familiar with Kubernetes. If not, no worries. So basically, in Kubernetes, you have this kind, which is kind of a type of resource you have you want to have in your Kubernetes. So in this case, we have kind pipeline, and then we have a spec, which is this the specification of what is in this pipeline resource. And so you can see there are parameters that you can add. So it can be, in this case, the repository URL for our Git repository. And then you can have a list of tasks. And in this case, we only have one task, which is Git clone. And so you would do a Git clone. And then, typically you would have multiple tasks that would do multiple things. And then the tasks themselves can be also a definition, a resource. So it would also be kind, task, something, where you would define your steps. And so, all that together makes for the resources that you need to run Tekton. Now, don't worry too much if this is too much kind of YAML and and too much of kind of things to remember, because you can create Tekton pipelines in different ways as well. So one of the cool things with Tekton is that you have a Tekton hub, where you can find a bunch of already predefined tasks that are out there, so you don't have to kind of reinvent the wheel and make a bunch of your own tasks. So there's quite a few, so you don't have to do too much. In my opinion, at least, I can always find a task to use. So you would go to hub.tekton.dev, and so let's take a quick look at that. Let's open my other browser, and so I already have the Tekton hub here. So you can see, excuse me, there are a whole bunch of different tasks that you can use to, for example, if I want to do a Maven command, there's there's a Maven task, and so that already has kind of a container image that it's going to run in, and then the steps to do something Maven, and it has parameters to say install or test or whatever. And so, you have a whole bunch of different tasks that you can use. So that makes it a little bit easier for sure. And then you have a UI as well that you can use with Tekton. So you have Tekton dashboard, which allows you, to build to build pipelines in a more UI way. And I'll show in a little bit exactly how you can use that. In my case, I'll use OpenShift to show it, but you can use upstream the community Tekton in your Kubernetes as well. So going back to the slides now, real quick. Oops, there we go. So and there's also a Tekton CLI, so you can also use the CLI to list and describe pipelines and to view logs and everything as well. Or you can embed it in your Kubernetes, and I'll show that in a little bit. So then that's the first part, right? Defining your pipelines, and that's all cool. But then how are you going to actually deploy your resources, your configurations to Kubernetes? You'd have some way of, you can do it in your continuous integration pipeline. You can define tasks to do that. But it would be even better if you could use something like GitOps, where it's going to be even more automatic. So what is GitOps? Basically, as the word already says, Git is used, and Git is a single source of truth for defining how you're going to deploy your application, how you're going to configure your application, how you're going to configure even other resources in your Kubernetes cluster. So you can basically have everything declared, as typically as code, as let's say YAMLs or JSONs. And so the nice thing about that is that you can use all your operations through Git workflows. So, you can, if you want to make a change to your deployment, you just make the code changes, you commit it, and then everybody can see, what changed, who changed it, and when it got changed, because Git is a single source of truth. And then you can use merge requests or whatever, just as you would with any other kind of, with your regular application. So, CI/CD versus GitOps, you can see here kind of, with CI/CD, you would have, well, you describe your desired state in some way. I want to deploy my new version of my application. You're going to go through your pipeline and then, well, push it directly to your cluster or something in an automatic way. But then what if something changes in the meantime? Then, there's not really a circular way of seeing what's going on. So with GitOps, the idea is that you push your changes. There's a GitOps engine that's going to notice, hey, there's a change in your desired state. So let's make sure that it matches with what's in my production or staging or testing environment on your Kubernetes cluster, and then it'll remediate by applying the changes that you have described to your cluster, and vice versa. Also means that it'll observe what's in your cluster, and if something gets changed there that wasn't in your desired state that you've defined in your Git, it's going to remediate that and basically reset your cluster to what it's supposed to be, what you've defined. And so that means that, if I go into my cluster, maybe that Friday night, and, I make a code change, or, well, I make a change of some sort, but I didn't commit it to Git. Well, you know how that goes, right? So, you change something and then you forget about it. And then next deployment, you overwrite that and you have the exact same bug again, right? So that's something that wouldn't necessarily happen with GitOps, because it would notice that, hey, does not match your desired state. So let's remediate it. So you can set it to do that automatically, or you can set it to notify you of, there's a change. Hey, Kevin changes in the middle of the night. You shouldn't be doing that. So you should probably remediate that by either committing what you've changed and then have GitOps automatically take care of it, or by, rolling back whatever you've done. So that's the idea behind GitOps. So why do we want to use GitOps? Well, like I already said, you can use your standard Git workflow, your familiar tools from the application development tools to do more, let's say, platform ops kind of things, like the configuration, like the actual deployment, like the configuration of your production environment. It enhances security because we're reviewing changes before we're applying them to our environments. It gives more visibility into who's changing it, when it's changed, and what changed. Which that also helps with the visibility and audits of what's going on your cluster, right? Because we can see that Kevin made this change 2 months ago that actually affected something that is happening today, but we can go back and see that, right? Without GitOps, somebody might have just changed a configuration or a plugin or something, and then we wouldn't know what changed or when that was changed. And it also helps with even multiple clusters, because you can use GitOps also, for multi-cluster kind of configurations, where you're actually defining how your cluster is configured, what should be deployed on that cluster, which operators are running on it, and everything. So you can define all that in Git and have very nice reproducible way to work with Kubernetes clusters. So the GitOps application delivery model then, so when we're delivering our application with GitOps, basically what's going to happen is, I make my code change and push it to my Git repository of my application. So these are the regular code changes, not the manifests or the configurations of my deployment. I'm just making code changes. We'll go through the CI pipeline, and we'll build a container from my artifact, and then we'll push that to let's say an image registry, right? And so this is exactly what's going to happen when we deploy our new version of our application, by the way. And so we push our image to the registry. We'll create a pull request that could happen from the CI pipeline. So as it's building the container, it's tagging it, it's pushing it to the registry, it gets the the exact digest, the very specific tag of your image, and then it can update your configuration Git repository. So where you have the configuration of how the application should be deployed, what is the configuration of your application, And then by changing the Git configuration, GitOps will notice that there's a change in your desired state and will automatically remediate by deploying our new version, because we've changed our tag of the image in our Git repository with the manifests. And so it's going to deploy that new version. The new image is going to pull that down because that's the desired state. So that's a way to use GitOps for application delivery to deploy applications. So here you can see kind of our circular GitOps way of monitoring for changes, detecting that there's a drift. Then we're going to take action to remediate and deploy our new version. And then we're going to continue monitoring, right? Because maybe I'll make a change on the cluster itself, or I push a new change, and so it'll remediate further, as we go along. And so one implementation of GitOps is ArgoCD. So ArgoCD, there's also FluxCD. There's a few other solutions. So in my case, I'm going to use ArgoCD. So ArgoCD is basically a declarative GitOps continuous delivery tool for Kubernetes. So you can declare exactly what your desired state is. And then you can handle your cluster and application configuration and have it versioned in Git, of course, and then automatically syncs configuration from Git to the cluster. So exactly what GitOps is supposed to do, right? And then drift detection, the visualization, it also has a visualization tool, and then the correction of your drift. So let's now do the deployment of our new feature in a modern automated GitOps way. So I'm gonna do some development to release our new version, and let's do some live coding, and it's gonna be really intense coding. So I hope you're ready for this. All right, so I'm gonna go to my Git repository here. This is my application. So I have my quinoa wind turbine, and so I'm going to do some development right on GitHub. So if we go to source, main, so remember how I said we're going to have a shaking feature instead of a tapping feature. So we're going to go to our web UI in this case. And actually what I've done is I've already developed this feature, and I just have a feature flag that I need to flip to release this feature. So the development has already been done. There's a way in the code to handle this. I just need to change a flag here. So let's do that. And this is going to be my hardcore development, right? So I'm going to change this to true, shaking true, and tapping false. And then that was my hardcore development. Pretty impressive, right? Okay, so I'm going to commit my changes. So I'll say enable shaking. And then, I could create a merge request, a pull request if I was, following the rules, but I'm just going to commit directly to the main branch because, because I can, I guess. All right, so I've pushed my changes. They went to my main branch. And so I have in my settings, I have a webhook that is pointing to a pipeline that's going to be kicked off because I made a code change. And so let's go look at this. So here we have, in my case, an OpenShift cluster. So this is a Kubernetes cluster. OpenShift is an implementation of Kubernetes that has, some extra features to make life a little easier in terms of using Kubernetes. So it's a nice UI. And so you can see here's my actual application that is running, and we can see it's running with 5 different pods, so for high availability. And we can see, so in addition to my application that's running as a Quarkus application, we can see a Kafka cluster that I've also deployed in my project. I have the caching database, an Infinispan database, and this is the trigger basically with an endpoint that my GitHub can point to. So when you create a trigger in Tekton, that's exactly what it'll do. So you declare that you want a webhook trigger endpoint, and then it'll create that. So that's the application. So now if we go look in OpenShift, you have not just Kubernetes, but for example, also conveniently Tekton can be deployed in OpenShift. You can either use Tekton, the Tekton operator, kind of the community one, or you can use OpenShift pipelines, which is exactly the same, except it's it's a version that's tested and stabilized by Red Hat. So, but other than that, it's Tekton. So in this case, I have that integrated here in my OpenShift. Again, you can use Tekton outside of OpenShift. You can use Kubernetes and Tekton and deploy it yourself. But you can see here, here's the pipeline that I've defined. And we have a pipeline run, which, as you remember, is the implementation of a pipeline, right? And so we can see here that we did a git clone. We did already a Maven build. And now it's building the container image with builda. And then after that, it'll update, and this what's happening right now. It's going to update my my manifest repository, which has the definitions of how to deploy my application, where it mentions, this is the container image that you're supposed to use. And so I'm going to change the digest of that image, and that's what's happening in this test. And so we'll see that in just a little bit, how that happens. I just want to show you that you can also, with Tekton, access the logs, of course, or here we can see the logs of what is happening right now. So we can see that it updated the Quinoa wind turbine manifest repository. And then in the previous steps, for example, because it's a Java application, we're using Maven. We did a Maven package for the application, and then here we did the container build and pushed it to our registry. And so we've updated our repository. And so if we go look now at the manifest repository, then we can see that if I refresh here, that's just now the Tekton bot updated the image digest. And so it updated the tag of my image to the newer version that was just pushed. And so by doing that, our GitOps process gets kicked off. So we have a ArgoCD installed on this cluster as well. And so if we go look at ArgoCD, we see here that there is a wind turbine application. So this is the UI of ArgoCD. And so we have an application here that we have defined with a deployment, with a route, and with a service. So that's a typical way of deploying an application in Kubernetes. And I'm gonna refresh real quick, and then you'll see here sync is happening. So a few seconds ago, a new version was pushed, says ArgoCD, and by doing that, you can see here that it's deploying new pods in our application with the new version. And so that's how everything kind of happens automatically. So you can see here, we're creating new pods, and then once those new pods are created, the traffic is going to shift to our new version, and the previous pods of the previous version are going to be shut down, so that our traffic is now going to the new application, and we have a new deployment, which is what has happened right now. So by just pushing my code, everything else was automatic, right? So I had my pipelines that created tasks, and so again, in Tekton, it creates the task, it spins up a container to do, for example, the git clone, stops it, it stores what's what was in my code. I added a persistent volume to my Tekton pipeline so that it stores, of course, some information that it passes on from task to task. But other than that, there's no kind of resources that are keeping on running. So there's just a volume that gets passed for my source. And for example, for my Maven cache, so that I don't have to download the entire internet every time. So that's what happened here in GitOps then. Is it detected that there was a change that was pushed by the pipeline, and that triggered the deployment of my new version. So that's what happened here in my cluster. And so we can see now we have, again, 5 pods running, but they're actually the ones with the new version. So let's take a look at our game. So here we can see that that was the previous version. I'm gonna refresh, and on this side you don't see really any difference, right? Because I only made a change so that you on your phone are gonna be pushing, or are gonna be shaking your phone. So everybody grab your phone, and we're gonna test out our new version. So let's go back to the slides to share the QR code again. And so in the meantime, I'm gonna pull this up to the side so I can see that people are signing up. So again, I'll scan the code again as well. So please do. So we have people playing, because otherwise it's not gonna be a very fun game. Okay, so you'll see now it shows enable shaking, right? So that's the new version that we've deployed. So this time, instead of tapping, we're gonna be shaking our phone. So go ahead and tap on the enable shaking, and then you'll see waiting for game, and then we'll be playing in just a minute. If anybody else wants to join in, now's the time. So scan the QR code, and then you'll be playing the game. Okay, waiting one more second. So hopefully everybody sees waiting for game. All right, so we have kind of an uneven distribution. So whoever the user is with Eland, you're the only one. So you may think that's a disadvantage. You're playing 1 against 3, but it could be an advantage, because the other 3 are gonna all have to shake, because it's the average that counts, right? So everybody ready to shake your phone, and hang on to your phone, because we don't want it flying across your room, right? So hang on tight to your phone. 3, 2, 1. Okay, and shake your phone. Shake it. Uh-oh, one of the cars isn't going, so whoever's in team 2, yeah, come on, shake, shake, shake. Team 2, come on, shake, 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 shake. Oh, a little late. Okay, should we start again? Oh, all right. Team 2, I like that you're shaking. Should we start again, and then we can have a fair race? We're waiting for team 2 to finish. They got some practice there. Okay, let's play one more time. So everybody hang on to your phone. We're gonna wait 1 second. So if you're still on your phone, you don't have to do anything. If anybody needs the QR code, put it in the chat real quick. Okay, so I think we're good. We got 2 against 2, so that seems a little more fair, right? So, we got 3 against 2. All right, anyway, ready to shake your phones again? This time we got 2 teams playing. Go, shake, 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 shake. Team 2, come on. Go, yeah, yes, there we go. Come on, team 2, shake, 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 shake that phone. Keep shaking that phone, team 2. Oh, they're catching up. Oh, it's just too late. All right, good job, team 1. And especially whoever user Eland was, you're the best phone shaker. So we can see this was a fun way to deploy a new version, all automated, right? And so I hope that was clear to you. Just a few more slides, and then I will be answering questions. So real quick, a shout out to if you would like to use OpenShift, you can use pipelines in there as well. And so you can just scan that QR code or go to that link. So developers.redhat.com, you get a free access to the OpenShift sandbox. So for 30 days, you can play around with it. You can create pipelines, which actually I did not show you, which I should have real quick. So if you want to create pipelines in the UI, that's possible as well. So you can do it with Tekton dashboards, or you can create it in OpenShift. So you can say like create pipeline, and then add tasks. So I can do git clone, and it's going to contact that Tekton hub for all the tasks that are there. So I can, for example, git clone, add to my pipeline. Then there's a red exclamation point, because I, of course, need to configure my parameters. I could add more tasks to say, Maven something, I can do gib maven to build my container image. And then maybe at the same time, I can do some testing of some sort. And so basically, I don't know what Orca init is, but so you can run parallel tasks where the containers are running at the same time. You can run them, kind of one after the other, and that's how you define a pipeline. Then you can do the same thing for tasks. So that's pretty handy as well. So back to my slides here. So that's with the OpenShift sandbox, you can do exactly that, right? So you can create the pipelines. There's also a GitOps cookbook that you can download for free here with this link. So red.ht GitOps cookbook. And then some more resources that you can access for free with the Red Hat Developer Program, even a book to modernize enterprise Java to that Quarkus that I was showing. And yeah, and just overall, join the Red Hat Developer. It's a free thing, so lots of cool resources and access to tutorials and all that good stuff. So with that, thank you for following, and let's see what the questions are. Okay, so I see Gabriel who says, Tekton has any kind of secret vault included? That's a good question. So because it is Kubernetes, it can use Kubernetes secrets. It doesn't have a vault included necessarily. So you will use, some like sealed secrets or vault or something that you would use in your regular Kubernetes. So it's not necessarily a specific Tekton thing. I hope that answers your question. And then let's see, we have Joao who says, hello, since you were using ArgoCD for GitOps, why not use Argo workflows instead of Tekton? Is there an advantage of one tool versus another? I think Tekton has a few more capabilities in terms of like actual CI. I think Argo workflows more CED focused, but I'll be honest, I'm not super familiar with Argo workflows. I'm more familiar with Tekton. So yeah, so, but I think Tekton is a little more focused on the CI part. Let's see what the next question will be. So we got Joao, another question. Can you share your thoughts on migrating from a traditional CI/CD to cloud native like you shared? Is there usually a resistance to change, or is a team maturity level required? That is a very good question. So in my opinion, or in my experience at least, yeah, you need some sort of level of maturity in your team to embrace kind of cloud native, right? So you have teams that are like, well, we're going to do Kubernetes because that's what we're supposed to do. But we're basically going to do a lift and shift of what we have, and we're just going to put it on Kubernetes. If you're working in a team like that, it'll be kind of hard to convince them. I mean, there are good arguments that you can use, right? Because you have reusable components, you can share tasks between different projects. You can, create different pipelines. You can have starter code for a different pipeline. You can have a lot of, you can have separation of concerns, use a lot less resources, have everything declarative so you can see, kind of how everything is built, who changed it, and whatever more. So there's a lot of good arguments that you can give. But, yes, I've had experience with, teams that are very traditional that are saying, well, I have my, kind of traditional CI/CD and I'm used to it and it works. And so why should I change? And yes, depends on the arguments there, I guess. I hope I answered your question. And if not, feel free to post another reply there. So let's look at the other questions. Are there any further?
Well, let's wait a little bit longer, Kevin, because there's a slight delay. But I gotta say, I had a lot of fun with the games. I was not the only one, because we had some people reacting with some car emojis. It was very fun.
Nice.
Well, assuming there are no other, oh, we do have another question coming up.
Okay, so do you include infrastructure resources as code in the pipelines? So yes, you could. Let's see. So in my example, what I did was I deployed, so I basically built a new application, but then I was actually building a container image and updating the resources of my manifest folder, right? You could use CI for actually more, let's say, infrastructure focused components of your Kubernetes, do some tests, and use GitOps to then apply those changes. But that could be part also of your CI pipeline. So you can be very creative, and depending on your use case, you can definitely integrate some CI or some infrastructure components in your CI, because at the end of the day, basically your infrastructure is now code, right? So you can handle it exactly the same way with Git workflows, and that also includes CI. So I hope that makes sense. If not, we'll see in the chat in a little bit.
Let's hope so. Let's wait a few seconds, but I will share also that João also thanked you for your answer, Kevin.
Excellent.
Well, as we see no other questions coming in, but I hope people will be able to reach out to you, Kevin, in case something comes up. So more people thanking you for your answers, Kevin. I would also like to thank you once again for taking the time out of your schedule to be here with us and giving us the opportunity of playing the games. It was very fun. And I hope to see you once again soon, Kevin.
Yeah, it was nice to be here. I hope everybody enjoyed it. And again, if anybody's at JNation next week, come see my session, or if not, come say hi anyway. Anyway, yeah.
Awesome. Thank you, Kevin. Bye.
Thank you. Bye.
So everyone, so it was a great session here with Kevin. I hope everyone enjoyed. Don't forget to keep an eye on our social media to keep up to date when our next live streams will be. And it was nice seeing you all today, and I hope to see you all in the next one. Bye-bye, everyone.